So in this video, I'm going to implement a stack in which we need to get a minimum element in the stack in a big of one time and big of one space. So let's say these are the elements that I'm going to push to the array, stack. So this is the stack. At each level, whenever an element is pushed to the stack, I'm going to store two values at each level. So when the first element is 13, when 13 is pushed, I'm going to store the 13 as well as the minimum element. So 13 is the first element until now, so the minimum element is also 13. And then we get 7 is pushed, and also the minimum element until now. So we compare the 7 with the previous minimum is 13. 7 is the least number, so we'll update the minimum as 7 for this. And for the next one we get 6, and 6 is smaller than 7, so the minimum element becomes 6 here. Now let's say we do this pop, we call the pop function. Then what we do is we'll pop the top element from the stack. Now let's say we call the minimum function. Since this is popped out, then the next element in the array we have is this one, and from this we get the minimum element from the top element of the stack, which is 7. So 7 will be printed out when we call this minimum element. So then let's implement this one. So class, let's say min stack, and in the constructor I'm declaring an array to store the elements that are pushed to the stack. Now let's write the push method. So push element, I'm declaring a variable called new min, and initializing it to 0. So if this dot array dot length is equals to 0, so whenever a push function is called with some element, and then if the array dot length until then is 0, then what we are going to do is we'll assign the element to the new minimum. So the element becomes the minimum element because that is the first element that is pushed. Else, if that is not the first element, then what we are going to do is we'll compare the element with the previous minimum. So for that what we are doing is new min equals to element this dot array of this dot array dot length minus 1, which means the last element in the array, dot min. So I am going to store the elements as an object. So in the object we have again two entries, two key value pairs. One is for the element and the second one is the minimum. So we compare the element with the minimum of the previous element. So if element is greater than the previous minimum, then in the new minimum we'll have the previous minimum as the new minimum. So this dot array dot length minus 1 dot min. Else if the element is lesser than the previous minimum, then we are going to replace the new min with the element. Now what we are going to do is we'll push into the array the new object as element as key and the input as value, and the second one is minimum, which is min. Into this we'll push the new min. So this is the push function. Now let's do the pop. In the pop function, I'm declaring a variable called popped. So if this dot array dot length is greater than 0, so I'm checking if there are elements in the stack, which means if stack is not empty, then in this variable so this dot array of this dot array dot length minus 1 dot element. So in the stack I'm just taking the last element. From that I'm taking only element because we have in the stack we are storing both the element and the minimum. So in this popped I am storing the element, and then what I will do is I will remove the last entry. So I am doing this dot array dot pop. Else, so if array dot if we don't have any elements in the stack, if the stack is empty, then we just return let's say -1 or just empty stack. So in this pop function we return the popped. So in the popped variable we have the last element in the stack. Now we need to we'll write a function to get the minimum of the minimum element in the stack. So I'm writing a function to get the minimum element. Here we need to write this function so that we the time complexity for this when this function is called should be big of 1, and the space complexity is also big of 1. So here I'm not using any extra space, and also to get the minimum we are storing all the minimums in the stack, right, in the form of min. So all we need to do when the minimum is called is we just get the last element in the stack, and in that last element we have the min entry, which contains the minimum element. So we're just gonna return that one. So this dot array of this dot array dot length -1. So this is the last element in the stack. In that we need only the value of key min. So now we have completed the implementation of stack, and to get the minimum element, all we are doing is we are just getting the element from the array, which is stack, the last element. So for any to get any element from the array from any index, that time complexity is big of 1. So for minimum function we are using big of 1 time, and since we are not using any extra space here, the space complexity is also big of 1. So that is all. So we can get the minimum element in the given time and space. Thank you.